Okay, yeah. So let's get into this. So my talk is going to be about LLM-powered personalization. We're going to talk about this. LLMs have taken the world by storm, and personalization has also been impacted. And the idea is to look at how this has happened and how we can apply LLMs to personalization use cases. So we will see a quick introduction to personalization and see some concepts as well. We will then focus on some ideas of how we can apply LLMs in personalization. And finally, we're going to look more in depth into how we apply this in one of our projects in BingeWiz. So if you're an engineer, we hope to inspire you with some ideas or awaiting questions that will drive you to dive deeper into this topic. And we'll share an overview of our model architecture and some ideas there as well. If you're a founder or a product manager, you will still be able to get how LLMs can be useful in this use case in personalization, which has applications across media, e-commerce, and marketplaces. So yeah, let's dive into this. First thing, what is personalization? Personalization is the act of tailoring an experience or communication based on information a company has learned about an individual. So just like the examples you see on the right there, so just like you may tailor a gift for a good friend, companies can tailor experiences or communications like emails, for example, based on information they have about their prospects and customers. And so, let's see some stats to see why personalization is so important. We can say that 91% of consumers say they are more likely to shop with brands that provide offers and recommendations that are relevant to them. 80% of consumers are more likely to make a purchase from a brand that provides personalized experiences. And 90% of US consumers find marketing personalization very or somewhat appealing. This means that personalization is a big driver of business impact, as most customers prefer personalized experiences and are more likely to buy in such case. So yeah, let's also see some concepts that we're going to see in this talk, and just to make sure that we're all on the same page in terms of understanding this. The first of these is embeddings. Embeddings are basically, they basically allow us to convert any concept or anything into numbers that make sense to our ML model. So a model can only process numbers. So if you want to process words, for example, embeddings is one way, using embeddings is one way to convert these words into numbers. And then another important thing regarding embeddings is that two concepts that are similar will be represented by two embeddings that are close together. This means that they maintain semantic relationships. So in one phrase, embeddings capture semantic relationships and enable algorithms to understand and process complex patterns and data more effectively. When we talk about users, these would be any prospect or customers or any individual that we are trying to target with our personalization. And the user actions are everything that the user does in our system and which we are tracking in the system. Finally, the items. When we talk about items, we refer to any product, content, experience, or whatever we're trying to match to the user. So this is what we're going to recommend or to show to the user. For example, items could be movies in a movie recommendation system or products in an e-commerce website or anything else. Now, let's dive into how LLMs can be applied to personalization use cases. We'll see some ways, some ideas how this can be done, but obviously there are many more. First, one way to do this is to get a better understanding of the items in our system. And one great way to do this is by embedding text features. LLMs are very good at embedding any type of text. In the past, most models would focus more on categorical and numerical features, and some some free text features would not be used. But right now, free text features like a description of a product or a user review can become really important, as we can really get a lot more benefit from them. So we can take all these textual features and also add in some categorical or numerical features, and like everything that we know about a certain item, put all of that into one text, send that to an LLM via API or by just calling the LLM model, and create an embedding for this text. And this embedding will kind of contain everything that we know about that item. And by including these text features, we are enhancing what we know about the items, right? So that's one way to get a better understanding of the items. And these embeddings, we can use them in multiple ways. We can build a model on top of them, or we can search for similar items by searching for similar embeddings. And we will see more of that later in the final section. So yeah, this helps understanding our items better. Another way of using LLMs to improve personalization is to use them to get a better understanding of our users. And this can be done, for example, by summarizing or classifying reviews. And also, we can do this by creating an embedding, a user embedding, by using a mix of user actions and reviews. Such an embedding can then also be used as input to a neural network or other use cases, similar to what I just said about the item embeddings. So by any of these two, by getting a better understanding of the user and of the items, we should get better recommendations or actions towards the user, like a timely email to avoid the user turning, or maybe recommending the item that the user was just looking for. So all of this is or will directly drive business impact. A third way to use LLMs here in this case is to present the results with a personal touch. So instead of just recommending an item, we can tell the user why we are recommending an item to that user. For example, in a movie recommendation system, as you see here in the screenshot, we can tell the user why the user would like that movie. For example, by adding a short phrase where we use an LLM to tell the user why this is exactly right for this user. So these are different ideas of how LLMs can be applied to personalization. Let's now get into more practical things, and we'll show how we applied some of these ideas in one of our projects. And we will get a bit more technical, but don't worry if that's not your strengths. You should still get a grasp of the things here. So first, let's talk about BingeWiz. BingeWiz is a web page that recommends movies that we build. It starts by asking the user to tell us 3 movies that the user likes, and then starts recommending based on that. It has 2 sources for recommendations, which are merged into a single list of 5 movies that are presented to the user. These 5 movies are what you see in the screenshot. So this is kind of the homepage. The 2 sources for these recommendations are, on one side, a 2-tower retrieval model that takes movie metadata and user watch history to retrieve a list of candidate movies. And on the other hand, we have a similar movie recommender. These candidates then get merged and are ranked by another ranking model. So there are different models in place here, and in all of these models we use LLMs. So let's take a look with a bit more detail into these different models. The first thing we had to do is to build a textual description of the movies that we want to recommend. We have a lot of textual metadata for the movies. So we use the OpenAI embedding API to create an embedding for each movie. We used the title, the overview, which would be something like a description, then the tagline, the genres and protagonists, which are the main actors and actresses. We put like all of these into one text, send that to the embedding API, and got embeddings which we can use in multiple places. The first place where we use these embeddings is to build a two-tower retrieval model, which I explained earlier. I have a diagram here to try to explain this a bit better. The goal of this model is to select a limited list of candidates from the whole database of movies. So on the top left, we have the list of movie ratings given by all users. We transform this to obtain a list of movies and ratings for each user. This is what we call the user watch history. So a list of all the movies that user has rated in the past. Then in the middle, we have the OpenAI API, which we call to get embeddings, as I showed before. And then finally, we have the movie database where we get some additional information about the movies. Like, for example, runtime, genres, and many other. So then the model, which you can see on the right, that's called a two-tower model because it applies a set of neural network layers on the user features on one hand, and then it applies a different set of layers on the movie features. So it's like two separate networks which are then combined to produce a single output. But let's go back to these inputs. The model takes as user features the user watch history, where it will take for each movie the movie embedding that we get from OpenAI. For each movie in the watch history, we don't use the user ID for training, just this user watch history, so just a list of movies, which results in a model that works for any new user as soon as the user has rated a few movies. This is made possible by using LLM embeddings and means that we don't need to retrain the model to support new users. And this is a great benefit. On the other side, on the movie features below, the model will take the same movie embedding that we use for the user watch history, and it will also add all the metadata that we have about a movie, and this will be passed, like all the metadata for one movie will be passed to the movie features, and that's passed to the model. And that's basically the diagram about this model. We also avoid using the movie ID during training in the movie features, because if we want to recommend a new movie, we would have to train on that movie ID. But now, as we're not basing on a movie ID we are basing the main feature on an external embedding, which we get from an LLM model. We can support movies that are not in the training dataset, and this allows cases where we can recommend movies that are new, like getting or coming out just like the past few days or weeks, without us having to retrain the model. And this is also a great benefit of using LLM embeddings in this use case. So, as mentioned before, the other source of recommendations where we also use the same LLM embeddings is to recommend movies by simply searching for similar embeddings to a movie that the user liked. For example, if the user gave the Toy Story movie a 5-star rating, we will recommend some movies that are similar to Toy Story, as the user will most likely like them too. So let's see which movies are most similar to Toy Story based on the embeddings we get from this LLM model. And as you see, you can see Toy Story 3, 2, 4, and many other movies which are indeed very similar or share several things with the Toy Story movie. And it's very likely the user will like these movies if the user likes Toy Story. So this is a very simple and effective way of recommending movies to the user. So wrapping up this section, I'm going to talk about the benefits that we have seen of using LLMs in BingeWiz. And the first thing is that we improved the model generalization. We noticed that the training metrics are much better using the OpenAI embeddings instead of learning these embeddings from scratch. In particular, we saw that validation metrics are much closer to the training metrics, meaning that the model generalizes better. Then, as I mentioned before, we can support new users and movies that we have not seen in the training dataset. And this is done because we depend on the LLM embeddings, and the model is designed to not depend on the movie or user ID. So this is a great benefit as well. Then we managed to use the same embeddings to also build a similar movie recommender. So we are like reusing the same embeddings in multiple models or algorithms. And finally, using the embedding API of OpenAI was very easy to integrate into our system, while the total cost for creating embeddings for all the 70,000 movies in our database was less than $3. So this use case, using the API for this use case is really, really cheap. And then wrapping up this talk, we have seen some short intro to LLM-powered personalization by looking at some ideas of how we can make this useful. And then also looking at how we did this in BingeWiz. So if you want to know more about any of this, we have written several blogs about BingeWiz and about ML in general as well. We invite you to read those. And also you can just leave your questions in the chat and I'll try to answer at the end.
Thank you so much, Mati.